Today we're going to learn about Nikola Tesla and his alternating current, also known as AC, and how it made possible the induction motor. Tesla was born in 1856 in modern-day Croatia. When he was 23, he moved to Paris where he worked for a company manufacturing electrical equipment. There he developed his first invention, an improved induction motor. He then took his invention to the United States, where he partnered up with George Westinghouse to form the Tesla Electric Company. Together, they built the first hydroelectric power plant at Niagara Falls. The company was very successful, and at one point had orders for more than 40,000 motors. But unfortunately, the partnership dissolved due to a disagreement over who would get the credit for the inventions. And so Tesla left the company and basically became destitute. He spent his last years in a hotel room, where he conducted experiments and performed demonstrations for anyone who would watch. He died in 1943 without really being recognized for his contributions to electrical engineering. Thankfully, today we have the technology to go back and give him the recognition he deserves. So today, we're going to look at some of his most famous inventions, alternating current and the induction motor. Now, these two inventions are actually separate inventions that happened independently of each other. But when you combine them together, you can make electricity from a distance. So that means you don't need to have your generator right next to your motor. You could put them miles apart and still transmit electricity. This made it possible to build huge power plants away from population centers, where people could safely live without having to worry about air pollution or noise pollution. Before Tesla invented alternating current, all the electricity used in homes and businesses came from direct current generators. A direct current generator works by putting a large coil of wire called an armature inside a magnetic field and then spinning the armature. The spinning motion causes the electrons in the wire to spin around and around until they break free and leave the wire. The electrons then flow out of the generator and into a circuit where they can be used to power things like lights or motors. The problem is that a direct current generator has a limited voltage, and the resistance of the wire that connects the generator to the load is constant. So as the load increases, the voltage drops. Also, if you try to increase the voltage by adding more turns to the coil, the current will decrease because the resistance stays the same. This is known as Ohm's law, where voltage equals current times resistance. So you can only change one variable at a time. Another problem with DC is that the current flows in only one direction. That makes it difficult to transmit over long distances because the resistance of the wires increases as the current flows through them. This means that to transmit electricity over long distances, you need high voltage, which is dangerous. It also means that you need thick wires to reduce the resistance. So you need both high voltage and thick wires to transmit electricity over long distances. To solve this problem, Tesla invented alternating current. With A, instead of spinning the coil, we keep the coil stationary, and we move the magnetic field by spinning magnets near the coil. That causes the electrons in the coil to spin around and around until they break free and leave the coil. The nice thing about this is that the voltage and current constantly change directions, which makes it easier to transmit over long distances. Now, this does not change the fact that the resistance of the wires increases as the current flows through them, so you still need thick wires. But now you don't need high voltage, so it's much safer. And that makes AC much safer to work with than DC. Tesla also invented the induction motor, which uses rotating magnetic fields to produce mechanical motion. It's called an induction motor because we induce a current into the motor by moving the magnetic field near it. To make an induction motor, all you need is two basic components. One is an air gap between two sets of magnets. The other is a squirrel cage made of conductive material placed next to the air gap. As the magnetic field moves past the squirrel cage, it induces a current in the cage. Now that current flows in only one direction, but the magnetic field is always changing direction. So the induced current changes direction as well. Where the current flows in the squirrel cage creates its own magnetic field. That magnetic field interacts with the magnetic field of the permanent magnets to produce a torque that causes the squirrel cage to spin. Now induction motors can be made to run at very low speeds for precise control of machinery, or they can be made to run at very high speeds for things like jet engine turbines. They are used in everything from small appliances to large industrial equipment. So that brings us to the end of our video. If you enjoyed this video, hit that like button and subscribe if you haven't already. We have lots of videos about electricity and magnetism.